Hello, everyone. I welcome you to the episode 3 of Chemistry of Selected Metals and Non-Metal. In this particular video, we'll be working on the chemistry of aluminium, which is group 3 element. And as you all know, group 3 elements include, we have the boron, we have aluminium, we have gallium, we have indium, and the last one here we have is what? Is thallium. But for this very video, a selected one is aluminium. So we'll be working with chemistry of aluminium, and aluminium is a selected metal. So please take note of that. For our second episode rather, we talked about sodium. For the second one, we talked about calcium. While for the group 3, we are working with aluminium. So aluminium is found in group 3 in the periodic table, as you all know, and aluminium is the most abundant element. Is the most abundant metal in the earth crust. So if aluminium is the most abundant metal in the earth crust, so what is the position of aluminium as an element? So the most abundant element in the periodic table is oxygen, followed by silicon, then followed by what? Aluminium. So aluminium is the most abundant metal, but is the third most abundant element on earth. And aluminium occurs as mica. Look at the formula for mica here. As corundum, look at the formula here. We have cryolite, we have kaolin, we have bauxite, and rock or clay as silicate what? Triazosilicate 4. So it can either occur as rock or clay, as a bauxite, as a kaolin, a cryolite, a corundum, or a what? A mica. So these are the sources of aluminium. Then how can aluminium be extracted? The process in which we use in extracting aluminium is called the Hoherot process. So if you use Hoherot process, you are going to extract aluminium. And how do we extract aluminium? We use what we call alumina, that is aluminium what? Oxide. Yeah, we use aluminium oxide. So whenever we reduce this, for the reduction of alumina, that's aluminium oxide, in an electrolytic process, what is going to obtain is called pure aluminium, whereby oxygen will be liberated to, let me give you a reaction. We have aluminium, let's say plus 3 electron to give us aluminium 3 plus. Then we have oxygen to give us oxygen plus 2 electron. So this is the reduction for the reaction. And as you all know, aluminium will definitely go to the cathode and oxygen will definitely go to the what? To the anode. And please remember, there's that we call cryo. So in the cathode, reduction will take place there, and at the anode, oxidation will take place there. So that is to say, aluminium is reduced while oxygen is oxidized in the reaction of which is the Heroth process of extracting aluminium. So please take note. The process is called Heroth, and alumina reduction by electricity is in dissolved molten cryolite. Alumina, which aluminum oxide is reduced when it is being dissolved in a molten cryolite in an electrolytic process. So aluminium is reduced, whereby at the end of the process, a pure aluminium is obtained. So what are the physical properties of aluminium? It's silvery, it's a silvery white solid, then it has a low relative density of 2.7. It is malleable, that means you can beat it into other shape. It is ductile, drawn into wire, moderate tensile strength. The melting point of aluminium is 160 degrees Celsius, and it is a very good conductor of heat and electricity. I never said it's a conductor. It's a very good emphasis on the very good conductor of heat and electricity. So that will take us to the next concept, which is alloy. An alloy is a combination of metals, non-metals, or metalloid. It's just a combination of elements. Let me use that. But most cases, we refer them as combination of metals. When metals are joined together, we refer them to as an alloy. So for alloy of aluminium, which is elements that are joined together, other elements that combine with aluminium to form a substance. So we have duraluminum, we have aluminium bronze, we have magnesium. So the question that will come is, which of the following is not a product or it's not a fraction from duraluminum. So for duraluminum or duralum, we have aluminium, we have copper, we have magnesium, and we have manganese. So for duralum, it has four products, which is aluminium. Four things came together to form duraluminum. We have aluminium, we have copper, we have manganese, and we have magnesium. Then for aluminium bros, we have copper and aluminium. While for magnesium, we have aluminium and magnesium. So please take note of what an alloy is and the three alloy of uh, of of aluminium. We have duralum, we have aluminium bronze, and we have magnesium. And please take note of what it consists of or what it's composed of. And something that is common here, here is aluminium, here is aluminium, here is what? Aluminium. So all of them have aluminium and any other element. It can be a metal, it can also be a what? A non-metal. But for aluminium, it must be a metal. And if you look at it so well, here is magnesium, copper, and manganese, and all of them happen to be a what? A metal. So what about the chemical properties of aluminium? So the first one we have the aluminium reacts with air. Option 2, aluminium reacts with non-metal. Or number 3, it reacts with an acid. 4, it reacts with alkali. Then the fifth one, it reacts with iron 3 oxide. When aluminium reacts with oxygen, it's going to give us aluminium oxide. So let's try and balance this equation. So here will be 2. Let's say here is 2. Here should be 4. And here should be 3. So it's going to give us aluminium oxide. So that's for the reaction with air. Then let's react aluminium with a non-metal. Let's say a chlorine. For this reaction to occur, we are going to have AlCl3. Let's confirm. Here should be 2. Yeah, it's balanced. So then for the next one again, we have aluminium reacting with HCl. So if aluminium should react with HCl, it's going to give us aluminium chloride plus what? Hydrogen gas will be liberated. Then for the third one again, we have aluminium reacting, the next one, aluminium reacting with alkalis. So when aluminium reacts with sodium hydroxide and H2O, is going to give us sodium aluminium hydroxide plus what? Plus hydrogen gas will also be what? Be liberated. What about when aluminium reacts with iron 2 oxide? So if aluminium reacts with iron 2 oxide, it's going to give us Al2O3, then iron will as well be what? Be liberated. So these are the reaction, the chemical properties of aluminium. Aluminium has the ability to react with air, which is oxygen. It has the ability to react with non-metal. It has the ability to react with an acid. It has the ability to react with alkalis. It has the ability to react with what? Iron 3 what? Oxide. So please take note of the reaction. Before we end this video, I want to ask you a question. The process by which aluminium is formed, the electrolytic process, please, the electrolytic process of producing pure aluminium or producing aluminium is called what? So please, if you know the answer, feel free to drop that in the comment section. And what you should take note of is what I'm doing here is just a summary of what is your textbook, what is your CH1 textbook. So we are summarizing the whole concept in the easiest way we can. And please don't forget to read alloy. For we have 3 here. We have duraluminum, we have aluminium bronze, we have magnesium. This is a very, very common question in JAM, not just JAM, even in your 100 level exam. You definitely see a question that is related to alloy of aluminium. And for the use of aluminium, we have it is used in the making of synthesis. It is used for overhead electronic table. It is used as a packaging material. We can even call this as a container. For example, our Mortina cans, we have our Coke cans, all those ones, they are from aluminium. We have building material, and the last one here, it is used in treatment of water called coagulation. So aluminium is used in coagulation process of water. So if you want to treat water, aluminium plays a part there. It is used in as a building material, windows, zinc, and the rest. So it is used as a packaging material or as a container or as cans. It is used in cooking utensils, then overhead electronic table. If you have any question based on what I've explained so far, feel free to drop that in the comment section. But don't forget, aluminium is produced electronically in a process called dash. If you know the answer, drop that in the comment section. For now, goodbye.